the American Rocket Challenge. So that's Friday and Saturday. And so I'm not available.
Okay. Yeah.
So,
As long as this is fine, I can just show you the video, then that's totally
mhm.
fine by us because we'd rather not reassemble. But yeah, with that, I'll share my screen and get started. So let's see, make sure this is right. Okay, so I just made some slides about the important stuff for our launch vehicle this year. So nothing's really changed from test launch except we had to remake the airframes, and we had to buy a new drogue, but I'll get to that in a bit. But working down from the top, we have our nose cone, pitot tube, and our COTS GPS all in the nose cone section. So, and then also ballast mass is attached to this upper nose cone bulkhead. So we do have that if you'd like to see it. If not, I'll keep going.
You keep going.
Okay. Then below the nose cone, sort of in the coupler for the nose cone, we have a downward facing onboard camera. Below there is our payload, which is basically a rotational spin stabilized camera. So that's also out here, so I can show you later. And that actually basically is looking out of a clear airframe section that's made out of butyrate. It's 3/8 inch thick butyrate. And we have analysis for that too to make sure it's strong enough, but it worked well at test launch. Um, then below that is our drogue separation. So our drogue's packed into the middle section. And then we have a piston separation system as primary and a charge canister as backup. And then this year is the first year that we have working fully SRAD student electrical and software avionics. So those are going to be actuating both of our drogue and main separation. Our main separation is a little more simple. It's just a primary and a redundant charge canister. Then we have a system called BLIMS that's basically flying as a bulkhead on the rocket. We're going to collect some data for it, but the idea is in future years we'll be able to steer our parachute with that system. But it's not quite ready, so we're just getting some data for it this year. And then that's separated by a bulkhead from our motor and motor mounting and fins and boat tail. So we're still kind of deciding between like 8 and 12 pounds of ballast and where we're going to put it. But our current wet mass is going to be 137 pounds and dry is around 116 pounds. So we have around 20 pounds of propellant. It's 14 and a half feet long, 6.17 inch diameter with the wrap. The stability at test launch was 2.55 calibers. So that's going to change a little bit depending on how much ballast we put in.
Mhm.
But it flew very stable and it was pretty much straight up and down off test launch. So we're not too concerned about that. And then with our current motor sim, the velocity off the rails 84 feet per second, and our target apogee is around 10,400 feet. So we had a surprise failure at test launch. So we had a nominal ascent and we went to 13,400 feet. But our drogue parachute failed. It basically broke at the seams, and we kind of saw some bad stitch patterns on it once we recovered
Mhm.
everything. And actually, because we had our onboard camera, so this in the top right is from our onboard camera, we were able to see that our shock cord from our drogue wrapped around a fin and then around the booster section. So it actually held the main separation from being able to separate. So both of our primary and backup separation charges went off, but the shock cords were holding the section together. So we had some pretty major airframe damage, and that's why we had to rebuild the airframe and rewrap everything right now. So because of that, we reduced. So we were running our student avionics as backup because we had never tested them before, like actually in flight, and they worked great, which was great. But actually, our primary RRC3 for drogue deployment got shorted somehow, and that's then we had a heavy delay on our backup avionics. It was like 3.4 or 3.5 seconds, and that's partially why our drogue blew up, but also we think it was just poorly stitched because we've deployed accidentally at way lower or way longer after apogee in the past years, and it's been fine. So still not really sure what happened there, but
Do you make your own parachutes?
no, we there was a Rocket Man Pro experimental
Mm.
drogue, and we had used a lot of those in the past, and they'd been fine. So um, we're switching for comp launch to I just talked to them, Valkyrie Recovery Systems Explorer drogue, and they said they're going to reinforce the stitching for our case. So I'm
Mm.
going to be a little bit more confident in that, and we're also reducing our SRAD electronics delay to around 1.3 seconds from apogee. So that and our RRC3 are going to be like we'll have a RRC3 delay of 2 seconds and a SRAD avionics delay of 1.3 seconds. So it'll have less time to fall to reduce that risk. And we also better sealed and reduced the volume of our main parachute section so that it has a stronger separation if needed. But I'm assuming that we won't have that same issue because it was kind of a one-off thing that I haven't really seen much before. Yeah, and then other than that, we went to 13,000 feet at test launch. Last year, we also went over by a few thousand feet. We went to like 12,400. So we kind of know what we need to do. We're going to add 8 to 12 pounds of ballast, and then we're also going to bore out our grains, basically reduce our total propellant mass so that we have less motor impulse. And yeah, again, our sim is at 10,400 right now. So we did that last year to pretty good success. So I'm not concerned about that.
Have you already done a burn test on the modified motor?
Yeah, burn sim.
Yeah.
Yeah, that's I can go to that. It's down.
Oh, okay. If it's
Yeah, I'll go back after, but yeah, we can drop the impulse by around 1,500 Newton seconds to take it from a low O to a high N motor. Um, and then that coupled with a ballast is how we're gonna um, drop our total apogee. And that's basically we did the same thing last year. We went to 12,400 at test launch, and then we bored out the grains and added some ballast, and then we went to 10,100 or something like that at competition. So I'm pretty confident that it'll work well.
okay.
Yeah, and then this is our assembled rocket. So this is post test launch. We did this last week, just a couple days ago, full assembly. And then I also have a video of the full assembly. This was without the motor in it, but you can see this, right?
Hmm?
Oh, no, it got paused.
Oh,
Let's see if this. I'm gonna reshare on the video. Alrighty, yeah. So I kind of just walked through everything here. So starting from the bottom, so that ring in there is actually our centering ring for the motor. And then you can see our fins are basically bolted with these CNC'd fin mounts to the airframe. And then we have these 3D printed fin mount covers over them. So yeah, right here is the fin mounts with the fin mount covers over them. That's just to make it more aerodynamic. And then our bottom rail button is right there. And again, our centering ring is those bolts in the middle, and then the upper motor bulkhead is the top there. Then in here is where our BLIMS system is and our other rail button, which is actually bolted into the BLIMS bulkhead. And then these bolts and those arming pins are for our SRAD electronics. So that's for our AV bay. And then there's a bulkhead on each side with amphenol connectors. So basically the AV bay is connected on both sides to our primary recovery. So our primary charge, our pistons on the drogue side, and then our charge canisters on the main side, which I'll talk about in a little bit. So this is where our drogue deployment pistons are located. And then up here is our payload with a clear airframe section. So again, it's a spin stabilized camera. So it's basically looking out through that clear section.
So I have a question. Why did you
Yeah.
put your main at the top?
Our main, so our
Your
main is
drogue at
actually,
the top
yeah.
and your main at the bottom.
So that's a design decision based on the fact that we were going to have BLIMS, which is the steerable parachute system located in the booster. So there was going to be a pilot deployment and then a parafoil, but we didn't quite get that going in time. So we have main deployment nearest to that BLIMS bulkhead. But we size the shock cords so that the main is going to be the highest thing in the sky when the parachute or when the parachute is about to be fully inflated. So the main shock cord is around, I think, 25 or 30 feet. I have it on another slide from the boost or from the middle section, so that it's going to be above everything else, even when we're under drogue once it's ready to deploy.
Yeah, I would say the largest reason we decided to put it in the booster section was in due to the number of sections we have and kind of the layout of a rocket. It was the only way that we could get that pilot chute and deployment bag to deploy vertically. So when you're deploying a ram air parachute, it needs to, deploys in a very systematic way, and none of the lines can tangle over each other. So with some recovery systems in a traditional chute, it's okay if the parachute comes out upside down because it will kind of, once it inflates, everything, kind of falls below the stack and it inflates. But with a ram air canopy, it has to be facing upwards when it deploys. So it's a little non-traditional, but like Ben said, we went through and carefully considered the lengths of the shock cords and made sure that that parachute would come out. And when it came out, it would be the highest thing in the stack, so it won't be hitting on any other airframe sections.
Yeah, I think another
So
part of that was, go ahead, sorry.
So your drogue is where your air piston is.
Yep, so our drogue, primary drogue deployment is our separation pistons. And then for main, we just have two charge canisters, a primary and a backup. Because we have a internal piston system. So last year we ran internal and external piston systems, but the internal piston kind of takes up too much space from the section for us to be able to deploy main with it. So we just went with the canisters.
And I'm wondering if the reason that your main wasn't able to deploy was, you said because the shock cord was wrapped around it.
Yeah, so we can, I could pull up a picture. I think I have somewhere.
Do you not think that that had something to do, that where your main and your drogue were had something to do with why that happened?
No, so the sections outside of the rocket. So the shock cord was wound up, and I can actually show you. Let's see.
Yeah, when the drogue failed, the two sections of the rocket just kind of chaotically fell around each other. So I mean, obviously the drogue serves to decrease the descent rate, so the deployment forces of the main aren't as intense, but it also serves to kind of,
Sorry, 1 second. I have to pull up the picture.
And
Okay,
we have
so
so
can you see the dock, or is it still on my
You guys are
video?
talking at the same time. I really can't hear either one of you very well.
Sorry, what was that?
You and Dean are talking at the same time.
Oh, my bad.
So I didn't hear either one of you very well.
Sorry, I was my volume was down because I just took out my headphones. But let me share this real quick. So if I zoom in here, basically our shock cord, while the booster section was falling, was wrapped like a vice between the two sections that were supposed to separate, and there was also a line behind our fin. So it basically was outside the rocket, preventing the separation of the two airframe sections because it got caught on some bolts. So yeah, it wasn't like, it was literally the sections did not separate. So it wasn't related to the positioning of anything really. It was just because our drogue failed and it started tumbling. It basically prevented the sections from separating.
But that might have been mitigated if you'd had your drogue in the bottom where it usually is. In the booster
Yeah, I mean,
section.
yeah, it's possible, but it also, we didn't have a drogue anymore because it broke at deployment. So the
Mhm.
canopy was just gone and we were
The recovery harness broke too.
What was
Or
that?
is that, it
So-
looks like your shock cord broke as well.
No, our shock cord was intact. So the sections were still connected when it hit the ground. And you basically can see where the suspension lines for the drogue were attached to our shock cord. So all that stuff was still intact, and the drogue actually broke at the end of each suspension lines. So it was like a stitching problem with the drogue, where it basically peeled off of the suspension lines.
I have a picture of it.
Mm.
Yeah,
I don't know how to do
yeah, I don't think it'll.
that.
But yeah, we're pretty confident with a stronger drogue that we won't have that risk. Because drogue deployment worked fine. It just literally exploded. And you can see kind of from our onboard video what happened and when that part happened.
Do you have the onboard video that you could play for me?
Yeah, so 1 second, that's in the drive.
You know, some failures are expected.
Yeah,
It's what you do later that matters.
It's here.
okay. Yeah, this was an interesting one because we were doing a lot of things similar to how we've done it in the past and never run into that video or into that issue, but it was a new one for us. So we're just gonna get a kind of overbuilt drogue. So you can see this guy, right?
I can see the field. Oh, yeah.
So again, our primary drogue deployment failed. So it waited 3 seconds for backup because we hadn't tested that system yet. And you can kind of hear and see when the deployment event happens, and then immediately the drogue basically breaks and pops off. So that's the deployment, and then that's when it broke. But you can see that the shock cords are still intact. Actually, I don't know if I'll be able to pause it right, but the oh yeah, there it is. So these lines right here,
That's from your
suspension line for the
parachute.
drogue. Yeah, and it basically just
Mm.
got destroyed somehow. And looking at the stitching pattern, it seemed like it was kind of poorly stitched. So that was kind of our main culprit. And obviously we could have run a shorter delay, but this was the first time we had run our own flight software. So we had a pretty big like moving average to make sure we didn't accidentally deploy early. But running the data that we got from this launch, we realized that we could run a lot lower latency on that. So we're going to use that as primary with like 1.3 seconds delay, and then probably drogue backup will be 2 seconds delay from apogee. So that'll be with the RRC3. And so then it's not falling as far before this happens too. But we're also just going to get a stronger drogue chute.
Yeah, I could see how if the drogue was stripped off, that the cord could wrap around your
Yeah.
rocket. I'm just not entirely convinced that putting your drogue in the top with such a heavy nose cone, because you're talking about how many pounds?
So
I mean, payload
the-
and ballast.
yeah, so the main thing is that our main chute, again, because of blims and also just because of the way the masses work out in the rocket, our booster section, so the bottom motor section, weighs about the same as the upper two sections. So it's basically 60 pounds in each of them. So 60 pounds in the booster section, and then 30 for the middle and 30 for the upper section. And then in the nose cone, we're only going to have probably around 2 to 4 pounds of ballast. So it's not going to be super heavy, and those two sections that are hanging from the drogue are going to be less than the booster section hanging from main. And we also have a 35-foot shock cord for drogue, so it's 15, or actually it might be 40 feet, 15 and no 10 and 25, yeah.
And how tall is your rocket?
It's 14 feet tall.
So that's a very short recovery harness.
So yeah, we're going for basically our key thing with the shock cord lengths was that we wanted to make the drogue descent and the main descent line up so that our sections weren't hitting each other. So the sections that are actually being separated are 5 feet and 4 feet. And then our longest section, which is connected by main, is 5.5 feet. So from the actual airframes that are being separated, it's a pretty big multiple of those lengths.
Okay, so your drogue, it should be the longest one, 4 to 5 times the length of the rocket.
Okay. Is it of the
So-
rocket or of the airframe sections? Because
Of the whole rocket.
okay,
Tip
yeah, we
to toe,
can.
14 feet. So 4 to 5 times 14 feet. And then, and this is so that you don't pull it apart at apogee
Mhm.
and have the
Separating.
main deploy at altitude and drift far. So
Yeah, so we did run a pretty similar layout at competition last year with it was actually shorter for both of them. But if you think that's necessary, we can figure out how much longer we need to make both of them. Yeah, our main shock cord is 60 feet long, but then drogue is 35.
you could do it the other way around.
Yeah, so I mean, the key thing that we were going for here is that the main and drogue like shock cord lengths and placements were long enough that even if the chute was stuck inside an airframe section, it would be long enough to pull it out. And then we added extra length to reduce chance of zippering. And then yeah, the main is the longest, but we want to also make sure that there's clearance for the main to deploy above the drogue when it's time for that to come out, which I think is why we were worried that our main was going to get tangled with the drogue since it's below it. So if we had like a 60-foot drogue shock cord, then the drogue would be deployed, and then the main would be going past the drogue as it's deploying. And we were afraid that if the main's not fully inflated yet and it's not past the drogue, that it might tangle. So how much longer do you think? So we're at like 3 times the airframe length. What is that? That's 30 plus 12. That's 42 feet. And then 4 would be 46 feet. So how much longer do you think we should make or 56 feet, I'm sorry, the drogue shock cords?
56.
56. Okay.
Yeah. And you could make the ones for the main shorter.
Okay. So just swap the main and drogue.
Yeah.
Should the
So
main
are you
be above-
pulling your chute out of a bag, or are you burrito wrapping it, or?
It's just going to be burrito wrapped. So it's again, we were originally going to go with the parafoil, but we're just going with a Rocket Man parabolic that's going to be burrito wrapped, and it's coming out of the middle section.
Could you not do, and I'm not talking about for this year, because your rocket's already built. And I don't think you can move your blimp now.
Mhm.
But would it not be better to put it in the avionics bay with your, in the same, in the
Yeah.
same section with your recovery? And
Yeah, so
then,
that was the plan actually is for next year in our
yeah, and then you wouldn't have to decide on alternative methods of deployment.
Mhm.
Uh,
Yeah, next year I think they're
Yes.
gonna go for a pilot shoot that is our drogue, and then it's gonna be one separation and then one main deployment event with like a pyro cutter. So it's all gonna be basically the rocket will just split into two sections and then main will be deployed by a pyro cutter. But yeah, unfortunately, this was like kind of originally planned to be parafoil, and then we switched to main, which had some implications for the placement of things. But I will say that again, last year's rocket had a similar thing where the once drogue was deployed, it was deployed from this section. The main still had to travel past it when it was deploying. So our actual separation after drogue is separated is pretty much the same as last year.
So if you're coming down under drogue, then so both your main section, no, it will be basically standing on its tail. It just makes it the deployment more complicated. Because we did see things like this year's SLI also had payloads in the nose this year.
Hmm.
And so they put their drogue in the bottom and their main in the top, and there were some issues.
Okay.
But I mean, you don't want to change it now with your
Yeah. Our key thing with the
way things are configured. You don't want to change it now.
yeah, with the shock cord sizing, our main deployment event is going to be functionally the same as how it was last year. It's just going to be the middle and booster sections separating instead of the upper and nose cone sections separating. But in terms of the position of the middle and booster, it's going to be exactly the same as our upper and nose cone were last year, or I guess it was our upper and middle section. And that worked pretty well. So for us,
Okay.
it's kind of a legacy thing. But that's why we were afraid of making that shock cord too long, because the longer it is, the more chance it tangles with main when main deploys.
Well, as it is now, your nose cone end will be pointing down when the main deploys. So it shouldn't be anywhere close to your drogue.
Yeah, and yeah, the other thing is that we sized our shock cord so that basically when everything's taut but the main hasn't inflated yet, the main is going to be above the drogue. So yeah, it's 4
Well,
feet from the booster section here. So this
it
is
usually
travel
is.
3 feet before inflation. So yeah, that's how we mitigated the chance of it all tangling together.
So what is your descent speed under drogue?
It's gonna be around 80 feet per second.
It could be a little faster. But and then under main,
Under main, I forget. See if it's
Should be around 20 feet per second, I believe.
how many?
20.
And what is your motor that you're using?
so our motor is a student research motor. It's a similar architecture to the one we used last year at comp, except we're threading in the nozzle and bulkhead. But we've hydrostatic tested and static fired and test launched it fine, so it's been working pretty well.
Do you work with somebody for the design of your motor?
No, it's completely student designed.
And you're comfortable with that, Dean?
Absolutely, yeah.
Yeah, we got first place in the SRAT 10K SRAT solid class last year. Last year we static fired 3 times and test launch and comp launch. So of this, the grains, and the motor design, we've done a total of 7 firings at this point. And we haven't had any failures at test launch or static fire. So we're pretty confident in our motor design. And we also hydrostatic proof tested it to the operating pressure that we're expecting just a couple weeks ago. So it's ready for comp.
Okay. Can you show me your hard points of attachment? Do you have any pictures of them?
Yeah, I have them here too. So we're using U-bolts. So these are our bulkheads are over here. So this is an example one. So these bulkheads are bolted into the airframe with these radial holes, and then we have a U-bolt, and then we have quick link and swivels at every connection point. So we're gonna put swivels at all the parachute connection points, and then at the connections to the parachutes as well. And yeah, those are pictures of the RSC3 mounting for those bulkheads.
Your bulkheads are aluminum?
Yep.
So are the boards on standoffs?
Yeah, so the boards are they're on standoffs on both sides. And then we have electronics mounting, and then to actually run the wiring, we have these amphenol connectors that seal the bulkheads. And then everything's radially bolted into the airframe. So the bulkheads act as a seal and also a mount for all the electronics.
Okay. Do you want to show me the rest of your slides?
Yes, so let's see what I got to here. So again, main separation is just some charged canisters. We're running 6.4 grams of black powder. I'll probably up that for the secondary, but we have a small volume that we're separating now. So we did a couple separation tests with that amount, and they work pretty well. So
yeah, I mean, just a little bit more, a couple grams more. That would be fine.
And then, for our drogue separation, we have our separation pistons, which are also over there if you want to see them. So we basically have a charge well in here that's sealed by a sealing plate. And the piston systems mean you use way less black powder. So this is around 0.4 grams. Just brought them over. So this is what they look like. The black powder goes right here, and then it gets slotted into the bulkhead like so, and then separates. So yeah, those have been also tested a bunch with 0.4 grams, and then we have canisters as backup, which are I think running 8 grams. I don't know if I wrote 6. Did I write 6 here?
I believe the backups are 4 grams because
really?
the drogue air.
Oh, it's smaller. But we can up that too if you think that's better.
No, if it worked on your charge testing,
Yeah.
and it worked on your flight, then it seems like your drogue that was a fluke, That
Yeah,
wasn't something that you guys, did. If it worked, it worked. Um, for your redundant one, I would, somewhere between 25% more and 50% more is what people generally do. Yeah.
alrighty, and then let's see what else. Yeah, so again, our parachute, we're running an 18-foot Rocket Man main with a 60-foot shock cord. We fold and tape the shock cords together so that the strip out shock is a little bit lower. And then our drogue was 35-foot parachute shock cord, and I'm getting a special 5-foot drogue from a company called Valkyrie that said that they could reinforce the stitching on the shroud lines just to make it less likely that what happened at test launch will happen again. And then we are also ordering some backups for that drogue. And then again, we're swivel linking all the U-bolts. So at each end of the shock cord is going to be on swivels, and then the chutes will also be on swivels where they're attached to the shock cord loop.
It's so weird.
And both of them are burrito wrapped in Nomex. Yeah, and again, our avionics bay is basically this housing for multiple boards that get connected to a backplane. So this is our primary system. The boards aren't in right now, but we do have it. It looks like the one on the right. And that one we vacuum chamber test before launch to make sure that it deploys things when it's supposed to. And then we have a separate RSC3 for main and drogue that are going to be as backup.
Okay.
Yeah, and then I showed you in the video, but the fin mounts are these CNC'd fin mounts that are bolted with 8 bolts to the airframe. And then we have these fin mount covers on the right that go over them just to make it a little more aerodynamic.
Yeah, I noticed that the bolts were sticking through on the inside with
Yeah.
nothing to cover them. How tight are they around the motor?
So they have pretty good clearance around the motor. So the motor's a 5-inch OD and our rocket's a 6-inch. So there's a good half-inch or so on each
What
side.
holds the motor in?
So I can show you that. I think it
Mhm.
might be, yeah. So this is our motor, assembled motor right here. So I showed you in the video the centering ring that mounts in the upper airframe. So that's to keep it from moving around. It's not a retention device. It's just to keep it from angling itself, basically, because we expect it to elongate a little bit when it gets hot. But then on this end, let's see if you can see. This is our nozzle and then our motor mount. So our motor mount basically transfers the thrust to the airframe. Sorry, I can't really get the angle here. So there's a flange right here that sits on the
Mhm.
bottom of the airframe. And basically it rests on a flange that's on the nozzle. So when we're under thrust, there's a flange on the nozzle that transfers the thrust to the flange that sits on the bottom of the airframe. So it's not being transferred through bolts. It's being transferred through those 2 flanges. And then we have this retaining ring here that mounts to the back of the nozzle. See if I can see that. So there's a bolt.
Okay.
This is what's retaining the motor to the airframe. So again, this is bolted into the airframe, but the thrust is transferred on the flange. And then our retaining ring is keeping it from falling out. And then over that, our boat tail gets mounted.
Okay. So, and what holds it at the other end?
At the other end, like at the top
Yeah,
end,
the forward end?
is the centering ring. So it's not
Okay.
constrained at both ends because it gets a little bit longer when it gets hot. So we didn't want to break the airframe sections from that expansion. But it's basically held in both directions at the nozzle. And then it's being centered by the centering ring.
So are the centering rings attached to the airframe?
Yeah, the centering ring is bolted to the airframe on the
Okay.
outside.
So that's why so many nuts and bolts.
Yeah, so the centering ring has a 4-hole pattern that is bolted to the airframe, and then the motor mount is also, I think it's a 6-hole pattern. And that's what you can kind of see here on this left picture.
Mm-hmm.
And I can pull up if you want to see a cross section. I think we have a in our reports. There you go. Oh yeah.
Yeah, I haven't seen the technical report.
Yeah, that's okay. So you can see kind of, sorry if it's a little blurry. The nozzle is connected to the motor mount, which is then sitting on the airframe. And then the airframe is also bolted into this 6-hole pattern, which is the thing you see right here.
Okay.
Yeah, and then I showed before, but this is our motor burn sim. So we're looking at around 1,200 pounds of thrusts at the rail, and around a 3.5 to 4 second burn.
And
our-
what is your thrust to weight ratio?
So that'll put us at whatever 1,200 over 136 is. So just do that. So that's around 8.8. Depending on how much ballast we
So
had.
what was your average thrust?
The average thrust is like 1150. Yeah, so I guess, and one key thing from test launch to now is that we're basically gonna bore out some of the propellant grains. So there's gonna be more initial thrusts off the rail than there was at test launch, but less total impulse.
Are you sure about your average thrust?
It might be, I could check what it was in the eng file, but this is a new motor sim, so the average thrust is around 1,000 to 1,100. But you can just see this is the thrust curve up here.
Mm-hmm.
And these have been verified by, again, we had 3 static fires last year and 1 static fire this year.
Because I'm getting a thrust to weight ratio of 30 to 1.
30 to 1. So our rocket's 100
Oh, never mind.
pounds.
It's supposed to be pounds, not ounces.
Oh,
I have a thrust to weight calculator.
okay.
Hmm. Now it says 1.9. There's something not right here. So 1150 average thrust. The rocket mass is 136 pounds.
Is it asking for newtons maybe?
You can. So is it 1150 pounds or
Yeah, it's 1150 pounds,
Oh, okay.
which is probably 5,000 newtons or so.
Ah. that does make a difference. Yeah, 8.46,
Okay.
84.83 feet per second off the rail.
Yeah, and I think
We
that's
take a
okay.
couple of feet off because, you know, can you show me on your airframe where your rail buttons are?
The rail buttons, so they're both on the booster. Let me go back to the other video real quick. So yeah, our bottom rail buttons right here, they're on standoffs,
Mhm.
so they make it past the bolts, and then the other one is right here. And we had our own rail, so we checked the alignment.
Okay,
So I'd say that's probably around 6 inches from the bottom, and then around 4.5 feet from the bottom. And we had no issues with them at test launch.
was there any, where did you launch?
We launched at Upstate Research Rocketry Group, which is in Pena.
Potter,
Yeah, in Potter, yeah.
are you guys gonna go to LDRS?
What was that?
Are you guys going to LDRS? It's gonna be there.
No, I
But
don't.
might be there.
Will
Sorry, hi, I've been here the whole time listening. I'm the other team lead. I
Oh.
might be going, but I'm not sure yet. I'm still figuring out my summer.
I can't, there's too many things happening for me in June. I'm not gonna be able to go either, but
I agree with Will. I might be coming back to launch another high power rocket. We'll have to see.
Yeah, I was at Earth last year and it was awesome. And I'd love to go to LDRS, but we'll see.
you just can't do everything. You
Yeah.
know? And because of Spaceport, I haven't made it to Earth in several years. But well, maybe next year. You never can tell. Alrighty. So that looks good. Really, the only issue I see is in the length of the recovery harness. Everything else has been, you know, tested under fire, so to speak, and I would guess that you're ready to go.
All right, awesome. Yeah, so you want it like around 50 to 60 feet for drogue.
Yeah.
Okay.
And are you using shear pins?
Yeah, so we have 4 shear pins for both of those sections.
For what size are they?
Are they 440, Dean, or 256?
Yeah, they are 440 shear pins.
Okay.
Okay.
I will say my one concern with extending the length of the drogue shock cord is just due to the way the geometry is, it's hard to maintain the length of the main shock cord or it's hard to maintain the length of the main shock cord if you're increasing the length of the drogue shock cord. So my only concern with increasing the drogue shock cord to 50 plus feet is that likely means that our main shock cord would be 70 to 80 feet. And at that point, I would be worried about the risk of tangling. So we can definitely try to work a way around that, but definitely just food for thought in terms of concerns of mine.
Yeah, you kind of have a different kind of setup. You're going to be separated in multiple places for the main. You know, and there is some concern about them banging against the booster.
Yeah. I will also say that the force of deployment, the risk of the force of deployment shearing the bulkheads or deforming the bulkheads or other recovery gear is less so with our rocket than other rockets because we make our bulkheads out of 1/4 inch thick aluminum.
I
So
wasn't
that's
really thinking about that. I was thinking about shearing your main shear pins when you don't mean to.
oh, okay. Yeah, that's a good point.
Yeah, it's all about don't drift onto white sands. We'll lose the field.
Mhm. Yeah, we will definitely try to increase the the length of that drogue shock cord as much as possible. Would you say there's kind of an upper bound to the length of the main shock cord that you would try to stay under?
It just doesn't need to be as long as the drogue. But generally you don't have multiple pieces of airframe with your main. Do they all have to separate?
Yeah, so we
All
just
the sections have to separate, or is it possible to bolt some of them together?
so I mean the only things that's separating is our drogue deployment event where upper and middle separate, and then our main deployment event where middle and boosters separate. So
Okay,
I don't think there's a way we can do that without those, but yeah, we'll just be in 3 sections. The only difference is that main is typically at the top, but this year we're going at the bottom.
okay, so.
And part of
um,
that decision is also so that we have sort of even weight. And again, that was for blims mostly, an even weight hanging from each section. So the booster weighs around 60 pounds, and then the middle and upper together weigh around 60 pounds. So we're kind of flying equal weight on each side of main.
mhm.
It's more important for the parafoil, but that's kind of why we decided to separate main there.
Yeah, you could, oh, so the drogue is up there. So for me, when I usually put the main parachute on anything as big as 6 inches, I usually I attach it to the nose cone. So that when it deploys, it is pulled out of the middle section. And then,
Since our motor is so heavy, since it's a student built motor, our motor weighs 54 pounds or something like that loaded. So it's the booster section is the heaviest thing. So the booster section will be actively pulling the main out of the middle section because it's heavier than both the middle and upper sections.
Yeah, and that's the weight of the nose cone is also another consideration in terms of not having the drogue attached to the nose cone. Because we want as much or not as much shock cord, but we want an adequate amount of shock cord to absorb the force of the drogue deploying. So if we were to attach the drogue right to the upper section where the nose cone is, there would be no shock cord to alleviate the force, and we would have a higher chance of the drogue ripping. Yeah, so another consideration we used in the lengths of the shock cords were the respective weights of each section and how much shock cord we have to dissipate the deployment forces.
Yeah, I think if we increase drogue shock cord length, so this is under drogue deployment. This section would be around 80 pounds or maybe 70 pounds when we separate, and then this one would be maybe 20 pounds, which is why we have longer shock cord going to our middle and lower section there. But we can definitely increase this 25 feet to 35 or 40 feet, so that it's
Yeah.
longer total drogue length.
because the drogue really doesn't hold much weight. It's just to keep the sections apart. And that's why you want a longer drogue chute, is a drogue recovery harness, is because so that they don't bang together, but you want them to drop pretty quickly. You don't, I mean, 83 is kind of on the low side.
Okay. Yeah, I was just talking to our new parachute guy today, so we can go back to the 4-foot drogue that they offer as well, which would put it at, I think, 95 feet per second.
That would be better.
Okay. It's also cheaper.
Alrighty then. Do you guys have any questions for me?
So I can just check HeroX as well. Is there still the flight safety review or the other call about
Is it?
sort of range stuff? I don't know if you remember
There's
last.
not another call. There's going to be a launch readiness. There's going to be another safety check on site.
Yeah, okay. And then for the video, where do we upload that? Or the recording of this?
There was an email address to send it to on
Oh
here,
yeah,
posted on
yep,
HeroX.
I remember now, thank you.
Yeah.
And you guys know to bring protective clothes, hiking boots or work boots. No sneakers or flip-flops out on the desert. There are critters. Drink lots of water, Gatorade, or your electrolyte replacement of choice. You know, the usual stuff. Lots
Yeah.
of sunscreen, a wide-brimmed hat, sunglasses. I'm busy.
Yeah, we have a big packing list that we made last year that people followed pretty well last year, so I'll be
And do
sending.
you have a checklist for a launch checklist?
Yeah, we do. So that's it's in our tech report, and also we have stuff on our Confluence for assembly and launch checklists.
They may want to see it printed out at
Yeah, I remember last year they
the
did.
safety review. If I was going to be there, I would want to see it. You're going to be at somebody else's mercy.
Mhm.
Sorry. It could very well be my husband. He's the lead on SRAD motor.
Okay, awesome.
So that's Ben Russell. So yeah.
Yeah, I guess with that, the one thing I was wondering, last year we had our motor assembled, so we weren't able to get it checked until actually the day of the launch because they didn't want us to bring it to the convention center. Is there, do you know if they're changing the way they do that, or is it gonna be sort of a similar thing where you can't really get your motor checked if it's loaded until the day of? Because we were considering just,
Yeah, you can't bring anything with propellant or any other energetics into the conference center.
okay, because this year, since it threads together, it's a little more simple, so we might be able to just assemble it after the convention part, so.
Wait, when's the next?
Yeah, I mean, you could bring the case and
Mhm.
your motor tube assembly that gets installed in, you could put that in. You just can't put the motor with, the actual propellant.
Okay. Sounds good.
Hello, kitty. Sorry, my cat's wanting attention.
Yeah, no, that is.
Alrighty, I think that's all
I
the
think we're
questions.
at
I have.
time.
Sorry, was that?
I said, I think we're at time. You can stop the
Okay.
recording.
Alrighty, thank you very much.
You're very welcome.
Thank you.
Thank you, Dr.
Have
Russell.
fun.
Thank
That's most of it. No, nobody.